So today in this class I am going to discuss about syllabus on hydraulic engineering. So everyone have joined? Okay. So let's discuss about syllabus. Okay. So basically in your syllabus you have 5 units which is based on 10 modules, and that is basically 10 modules. And module 1 that consists of laminar flow, module 2 turbulent flow, module 3 boundary layer analysis, module 4 dimensional analysis, module 5 introduction to open channel flow, module 6 uniform flow, module 7 non-uniform flow, module 8 hydraulic jump, characteristics of hydraulic jump, module 9 flow through pipes, module 10 computational fluid dynamics, that is CFD. Okay. So let's discuss about first unit, module 1. Okay, let me share one screen to you. Wait for a minute. Okay, is this visible to you, all of you? Okay, yes or no? Okay, so in your first chapter you have laminar flow through circular pipes, annulus and parallel plates, Stokes laws problems, and measurement of viscosity. In module 2, you will learn about turbulent flow, Reynolds experiment, transition from laminar to turbulent flow, definition of turbulence, scale and intensity, causes of turbulence, instability, mechanism of turbulence and effect of turbulence, flow in pipes, Reynolds stresses, semi-empirical theories of turbulence, Prandtl mixing length theory, which is a very important one, universal velocity distribution equation, resistance to flow of fluid in smooth and rough pipes, Moody's diagram, and some numerical problems you have to do. In module 3, you will about to learn boundary layer theories, boundary layer analysis, assumptions related to boundary layer, concept of boundary layer theory, boundary layer thickness, displacement, momentum, energy thickness, laminar and turbulent boundary layers on a flat plate, laminar sublayer, smooth and rough boundaries, local and average friction coefficients, separation and control. Okay, so as I have told you, in module 2 you will about to learn Reynolds experiment. Basically in our lab this apparatus is not available, but you have to learn virtually with YouTube videos and all. Okay, so transition from laminar and turbulent flow, which is described by Reynolds experiment, and after that he gave some definitions related to turbulence, scale, intensity, causes, instability, mechanism, and other theories. Semi-empirical theories, velocity distribution equation, resistance to flow of fluid in smooth and rough pipes, Moody's diagram, and all these. Okay, let's discuss another module. In module 3, you have boundary layers, analysis, assumptions, displacement, momentum, energeticness, laminar, and turbulent boundary layers on a flat plate, laminar sublayer, smooth and rough boundaries, local and average friction coefficient, separation and control. Okay, everyone, I think you have got a rough idea about these 3 modules, isn't it? Okay. Let's discuss about next module. So let me share another screen. Okay, in the next module, you have dimensional analysis, hydraulic similitude, dimensional homogeneity, Rayleigh's method, Buckingham's pi method, and other methods. Dimensionless groups, similitude model studies, types of models, application of dimensional analysis and model studies to fluid flow problem. Again, in next module, Module 5, you have introduction to open channel flow. Okay, let me tell you one thing. This is the new chapter added to this subject. Previously, you don't have this chapter in your syllabus. Basically, open channel flow, the subject can be considered as an elective subject, but they have made it compulsory for you so that you also get to learn about open channels and their characteristics, utilities, purpose, and other methods. Okay, so in this open channel flow, you have comparison between open channel flow and pipe flow. So there are some basic differences between open channel flow and pipe flow. Geometrical parameters of a channel, classification of OCF, that is uniform flow, non-uniform flow, rapidly varied flow, that is also known as hydraulic jump, gradually varied flow, and velocity distribution across such channel section. In next module, you have details about uniform flow, continuity equation, which is the governing equation of uniform flow, energy equation, momentum equation, characteristics of uniform flow, Sage's formula, Manning's formula, factors affecting Manning's roughness coefficient, most economical section of a channel, competition of uniform flow, and competition of normal depth. In Module 7, you have a detailed syllabus on non-uniform flow, specific energy curve, critical flow, discharge curve, specific force, specific depth, and critical depth. After that, you have measurement of discharge and velocity. Okay, let me tell you some measuring instrument of discharge. These are Venturi flume, standing wave flume, Purcell flume, broad crested wave, and measuring instrument of velocities are current meter, floats, hot wire anemometer, gradually varied flow, dynamic equations of gradually varied flow. Okay. After that, you have classification based on channel bottom slopes, classification of surface profile. Classification of surface profile is computation of water surface profile by graphically and numerically and some analytical approaches. Direct step method, graphical integration method, and direct integration methods. These are the methods you have to study in this non-uniform flow chapter. In the next module, you have hydraulic jump. As I have told you, hydraulic jump is also called RVF, that is rapidly varied flow. In this chapter, you have hydraulic jumps, these theories of hydraulic jump, elements of hydraulic jump, its characteristics, and hydraulic jump along a rectangular channel, length and height of a jump, location of jump, types, application, and location of this hydraulic jump, energy dissipation and other uses, Charge as a moving hydraulic jump, positive and negative charge, dynamic of fluid flow, momentum principle applications, force on plates, pipe bands, moments of momentum equation. So basically these are your numerically based chapters where you have to solve lots of numericals and deductions related to hydraulic jump and related to OCF also. Okay. Everyone, write your enrollment IDs in chat box so that I can mark your attendance later and upload it in ERP. Okay. Is that clear to you up to this? Okay. If you have any doubt, you can ask me directly, no problem. Okay. In the second last module, that is module 9, you have flow through pipes, loss of head through pipes, Darcy-Weisbach's equation, minor losses, total energy equation, hydraulic gradient line, pipes in series, equivalent pipes, pipes in parallel, flow through lateral pipes, flows in the dead end of pipes, siphon, power transmission, flow through nozzles, analysis of pipe network that can be done by one method called Hardy-Cross method, water hammer in pipes and other control measures, branching of pipes and 3 reservoir problems. In the last chapter you have computational fluid dynamics, basic equations of fluid dynamics, grid generation and introduction to CFD and hydroinformatics. Okay, everyone, have you marked your attendance in chat box? Okay, anyone left? Write your enrollment number. Don't forget to write your enrollment number in the chat box. Roll number 77, 95, 83, 103. Okay. Don't forget to write your enrollment IDs. Once again I am telling you. Okay, so it's fine up to this. Okay. Actually I will discuss about your chapter 1 in the next class. Is it okay for you? Okay. Then you can refer some textbooks. I am giving the names of the textbooks which you can refer, and these are Hydraulics and Fluid Mechanics by PM Modi, Theory and Application of Fluid Mechanics by K. Subramania. Open Channel Flow by K. Subramania. Open Channel Flow Hydraulics by Van T. Chow. Okay, let me show you how laminar flow occurs. Let me tell you about laminar flow. Okay. As we know, laminar flow is also known as streamline flow, as it is flowing through one direction. The flow of a real fluid is more complex than that of an ideal fluid, owing to the phenomena caused by the existence of viscosity. Viscosity introduces resistance to motion, isn't it? So, after what will happen? It will cause shear stress and friction between fluid particles and boundary layers. For flow to take place, work must be done against this resistance force, and it is possible only when there is low velocity and high viscosity of the fluid. Okay, so in this process, energy is converted to heat. The inclusion of viscosity also allows the possibility of two physically different flow regimes. The effect of viscosity on the velocity profile also render invalid the assumption of uniform velocity distribution. Although the Euler equations may be altered to include shear stresses of a real fluid, the result is a set of partial differential equations to which no general solution is known. Okay. And a fluid flow occurs when no disruption, that means when there is no obstruction, then only laminar flow can occur. You can note it down. Whatever you have shown in the screen, you just note it down. It is very important, and I will share the class notes later. Okay. Let me share another screen. Okay. Can you see the two different flow? The upper one is laminar flow and the lower one is known as turbulent flow. The difference is extremely visible in this diagram. As you can see, laminar flow, the fluid particles are traveling in a straight path, but in turbulent flow, the fluid particles are traveling in a zigzag way. Okay, this phenomenon is described by one scientist called Reynolds, and he derives one formula to distinguish between laminar flow and turbulent flow. He derived one formula known as Reynolds number, which is given by Re equal to inertia forces by viscous force equal to rho Vd divided by mu, where V is the mean velocity of the fluid in a pipe, d is the diameter of the pipe, and rho is the specific mass, mu is the dynamic viscosity, and mu is the dynamic viscosity. I think this term you have already known and already discussed about this term in your 4th semester of fluid mechanics, isn't it? Okay. So he described this formula and he put some upper limit and lower limit of laminar flow, which is given by 2100 to 4000. In between 2100 to 4000, the flow is called transitional flow or translational flow. Okay? All of you note it down. Whatever I have discussed, whatever I have shared to you, all of you note it down. In laminar flow, the fluid particles are constrained to motion and parts by the action of viscosity. Have you seen RE? Okay, this Reynolds number limitation is 2100 to lower limit 2100, upper limit 4000. That means if Reynolds number is less than 2100, the flow is said to be laminar, and if it is more than 4000, the flow is called as turbulent flow. In between laminar flow and turbulent flow, the flow is called transitional flow. Okay. The instability of laminar flow at a high Reynolds number causes disruption of the laminar pattern of fluid which is in motion. With sufficient disturbances, the result is known as turbulence, and gradually turbulence leads to turbulent flow. Is that clear to you? Any doubt? If you have any doubt, you can ask me directly or you can write in the chat box. If anyone's network quality is not good, you can write it down. Okay. Let me share the screen. Here I am showing Reynolds experiment. Which describes the effects of viscosity and causes the flow of a real fluid and the condition of two regimes, that is laminar flow and turbulent flow. Okay, let me give one examples of laminar and turbulent flow. This is a basic examples and everyone is familiar with this, I think. What is this? This is a wash machine. You can see the flow from a tap is laminar, and when it is struck in the basin, it will get turbulent, and this is called turbulent flow. Okay. Okay, so in the next class I will discuss about two-dimensional flow of real fluids, some basics equation of laminar flow and turbulent flow. Okay, let me stop for today. Thank you all of you.